Okay, we're going to find out if this sequence converges or diverges. We have arctangent of the natural log of n. The way you find out if something converges or diverges is by taking the limit as n approaches infinity. So we have the limit as n approaches infinity of this thing here, arctangent of the natural log of n. So what we can do here is just go ahead and plug in infinity. If we plug in infinity to the natural log of n, what do you get? The way you know what you get is by thinking of what the graph actually looks like. What is natural log of n? Natural log of n has this vertical asymptote here, and then it crosses the x-axis at 1. So it's 0 there is at 1. And then it just keeps going. It just keeps going and going and going, but it just keeps going and going and going and going. It doesn't seem like it's increasing, but it is increasing all the way up the y-axis for eternity. It just seems to be going that way, but it is growing. You know, there is no asymptote here. So it goes to infinity. That goes to infinity, and therefore we're evaluating the arctangent of infinity. And what is the arctangent of infinity? Again, you have to think of what is arctangent? What are we really talking about? Arctangent looks like this. Arctangent is kind of like that. It's the sort of flipped version of tangent. So with this one, it actually does have some horizontal asymptotes here, which it never crosses. It never goes above these at all, because this is just like tangent. It's got pi over 2 and negative pi over 2 as the y values here, upon which it never crosses. So if we're going to positive infinity, if we're just going on and on and on in that direction, what are we going to approach? We're going to approach pi over 2. That is the limit. That is how the limit is defined as we approach infinity. So we have the limit as n approaches infinity of this sequence is pi over 2. So we say that it converges because that's an actual value. It converges to pi over 2.